solve this question. Example 2, and here the question is, consider the upward flow of water through a layer of sand. This is upward flow, and given that void ratio is 0.52 and specific gravity is 2.67. The first question is, calculate the total stress, which is sigma, and pore water pressure U, and effective stress sigma prime at points A and B. So this is point A, this is point B. Okay, and this is the groundwater level. So basically there has two layer. This is one, and this is two. This layer is sand, saturated sand layer, and this is only, this has only water. So calculate the total stress for point A. Total stress, we know the total stress formula is distance into unit weight. So first distance is 0.7 for this zone, and this zone is has only water. So water unit weight plus, this is point A, and this distance is 1. So distance is 1 into, and this is the saturated zone. So saturated unit weight. Okay, let's see. Given that void ratio is 0.52, specific gravity is 2.67, and we know the formula is for saturated unit weight equals to water unit weight into specific gravity plus void ratio divided by 1 plus void ratio. Here the water unit weight is 9.81 kilonewton per meter cube, kilonewton per meter cube, as the parameter is given in meter. So this value will 9.81 kilonewton per meter cube, and specific gravity is 2.67, void ratio is 0.52. So the saturated unit weight will 20.59 kilonewton per meter cube. Okay, okay. For point A, total stress equals to distance into water unit weight. I already discussed distance into water unit weight plus distance into saturated unit weight. So distance into saturated unit weight, which is 20.59. So the total stress will 27.46 kilonewton per meter square. Okay. Next question is, find pore water pressure at point A. So the formula is pore water pressure. Pore water pressure, the formula is distance into water unit weight. As the question is for water pressure, water, so the formula is distance into water unit weight. Okay, so for point A, the total distance is 0.7 plus 1. 0.7 plus 1. Okay, 0.7 plus 1 into water unit weight. Okay, as there there is there is water here also, so this needs to be included, and that's why the formula will plus H divided by H2 into Z into water unit weight. Here Z is elevation, so the elevation will, this is point A, so elevation will, this distance is 1 meter. Okay, elevation value will 1 meter, and h is, and small h is 1.5 meter, and h2 is 2 meter, this distance. Okay, let's insert this value. H is 1.5 and h2 is 2 meter, elevation is 1, and we know water unit weight is, this is fixed value, 9.81 kilonewton per meter cube. Okay, then pore water pressure will at point A 24.03 kilonewton per meter square. Okay, next question is calculate effective stress. Okay, the effective stress will, we know the formula is, effective stress is total stress minus pore water pressure. So we get total stress is 27.46 and pore water pressure is 24.03. So effective stress at point A will 3.43 kilonewton per meter square. Okay. Okay, our next question is, there is another question, calculate total stress, pore water pressure, effective stress at point B. So we know total stress, is distance into unit weight. Here for point B, the total distance is, this is zero point 0.7 and this is 2. Okay, for zero point 0.7 this is only water zone, and for only 2 meter this zone is saturated sand zone. Okay, so the distance zero point 0.7 multiply with water unit weight plus this distance is 2 meter and multiply with saturated unit weight. Okay, then total stress will 48.05 kilonewton per meter square. Okay, the next question is find pore water pressure at point B. We know pore water pressure, the formula of pore water pressure is distance into water unit weight. Okay, please memorize this. Okay, our formula is pore water pressure U equals to distance into water unit weight. Here for point B, the total distance is, this is groundwater level for point B. The total distance is, this is 1.5, this is 0.7, and this is 2. So the total distance will 2.7, 1.5 into water unit weight. So pore water pressure at point B will 41.2 kilonewton per meter square. Then effective stress will total stress minus water pore water pressure. Okay. Then we get effective stress will 6.85 kilonewton per meter square. Okay. Our next question is, what is the upward seepage force per unit volume of soil? Okay, we know the formula of upward seepage force per unit volume is I into gamma W. Here I is average hydraulic gradient, which means the ratio of distance to distance h divided by h2. Here small h is 1.5 and h2 is 2. So I average hydraulic gradient will 0.75, and we know gamma W water unit weight is 9.81. So the upward seepage force per unit volume will 7.36 kilonewton per meter cube. Okay, thanks for watching my video.